Nodal analysis with voltage source, which means the circuit involved with voltage source. For example, here there are two voltage sources here, and this voltage is in between the node and the reference node, and this voltage source is between two nodes. So to carry on the nodal analysis, first we need to define a reference node, which is here, and then we found node 1, node 2, and node 3. Okay, so there are three nodes. So we need to find the node voltage on these three nodes. Let's look at this node here, first node. The voltage on this node actually equals to the voltage on this voltage source. Normally the voltage source, the voltage is given. Therefore, the voltage on node 1 is known already, which means that, for example, if I have Vs1 equals 10 volt, then this voltage V1 equals 10 volt already, which equals to Vs1. So look, this is a notation here. This is a voltage on the source Vs1. This is the voltage on the second source Vs2. The voltage here V1 here is equals to Vs1. It does not mean that, okay, this node is Vs1. This node 1 and this node 1 should not be the same. Three nodes here, we figure out one already. We need only two nodes to solve. Two node voltage to solve, which is V1 and V2. So how do we solve V1 and V2 here? The effective way is to form a supernode, which is a boundary. The boundary is actually to bypass this voltage source, because the current flow this voltage source here, either this or that, it doesn't matter, the sign which is given though. The current flow into this voltage source, any voltage source, we cannot use Ohm's law. Therefore, we need to bypass the current flow through this voltage source to reduce one more equation, because if this is I call it I0 maybe. This is a new unknown. So we need one more equation to figure out I0, I0. We don't want to do that. It's doable, totally doable. It's just extra steps. We don't want extra steps. So what do? We form a boundary. A boundary bypass this voltage source here. And then we apply KCL on this boundary. All the current flow into this boundary equals the current flow out of this boundary. The current direction here we define like this here, I1, I2, and I3. The current flow into I1, it should be I1 equals to I2 plus I3. Current flow into the boundary, this is a boundary here, right? And then equals current flow out of the boundary. Next step is to use Ohm's law. What is I1? I1 equals to the node voltage here on this node minus the node voltage on this node, which is Vs1 minus V1 divided by R2. What is I2? I2 is, let me erase this, the notation here. I2 is the node voltage on V1 on this node here, which is V1 divided by R1. So let me write it here. This is V1 divided by R1. That's I2. What is I3? I3, that's this node voltage, which is V2 divided by R3. Okay, so now we have how many unknowns? V1 and V2. Right now, we only have one equation, so we need another equation. Another equation, which is V1 minus V2 equals Vs2. This is a given, so this is another equation. Now we have one more equation, and together with this equation here, we can solve V1 and V2. Once we solve V1 and V2, we can find I1, I2, I3 easily.